Alright, hi everyone. So this is the revision video for topic 4, which is circular measure. So this chapter is actually a pretty short one. So if you can recall, in topic 3, we learned about equation of circle, right? So this topic is actually different from what you have learned in topic 3, which we talk about how do you actually find the equation for the circle. So instead of finding the equation in this topic, we are only focusing on how do you actually find out things like arc length or area of sector or things like area of a segment and so on. Okay, so in this chapter, it also very helpful for you to know some of your prior knowledge in triangle, which involve maybe your right angle triangle or even the sine rule and cosine rule, and also how do you actually find out the area of triangle if let's say it's not a right angle triangle. Okay, so these are the things that we'll be doing revision on so that it will be helpful for you when you try to solve the questions. Okay, so the first thing that we learn under this chapter, right, is the definition of radian. Okay, so I'm not going to repeat that here. So what is important is you know how to change a degree to radian, right? Okay, so if you want to change degree to radian, so meaning that you have an angle in degrees. So if you want to change it to radian, then you will multiply with pi over 180. Okay, so on the other hand, then if let's say you want to change radian to degree, then you will be multiplying the opposite side, right? So which means you have radian, then you want to get degree, then it will be multiply 180 divided by pi. Okay, but normally in this topic, because we are using the formula of S equals to theta r and so on, so which the formula will be more focusing on all the angle is in radian part. So that's why for the first part will be much more important. So that's like rarely that you have a cases where you need to change from radian to degree. Okay, so some of the important thing that you should get very familiar already is that for example pi radian is actually the same when we say 180 degree. So which means if we have pi over 2 radian, it actually means the right angle, okay, which is 90 degree. So if let's say it's 2 pi, then it will be 360. Okay, so this is about how do you change angle in degree form to radian form. Then after that, we are going to look at two formula here. So this is a sector. So we know that this is like theta, so which means the angle that's subtended by your sector here, and this is the radius. Okay, so if let's say this is a radius, then same thing, this is a radius as well. And if you try to draw a circle, then this is a place where you are having your center of your circle. Okay, so the first thing that we know is how to find arc length. Okay, so arc length is the length for this part. So this is your S. So we will normally use the short form S. Okay, so how do we find S? Then S will be equals to R theta. Okay, so R is the radius, and theta is your angle in radian. Okay, please make sure that when you try to use this formula, your theta must be in radian only. It cannot be in degree. Okay, then the second one we learn is how to find the area of sector. Okay, so area of sector, then normally we try to use the word A. All right, so how do we find A? So A is equals to 1 over 2 r squared theta. Okay, so same thing, your r is your radius, theta must be in radian as well. Okay, then the next one, we learn how to find for example, you have a chord. Okay, so this is like the chord. All right, so how do you actually find this? So we say that if let's say you do not want to memorize the formula, so from what we discussed in the classroom, right, we say that you can always just cut the triangle into like half, so you can get like a right angle triangle. So with this angle here, then you'll be able to get your theta divided by 2, right? So if let's say this is for example 30, then you might get 15. Then after that, with your radius, then you'll be able to use your SOHCAHTOA to actually solve this. Okay, but if let's say you think that you do not want to think of so much of the thing in your exam and you want to just memorize, then you can just remember that. But if you want to use this, you must make sure that it's a chord. All right, so a chord meaning that it must be. So if let's say the sector is like this and the part that you want to find is here, so this is definitely not a chord, so you cannot use this formula. So if you just want to remember the formula, then something that you can remember is the length of the chord, which in this case is AB. Okay, AB will be equals to 2r sine theta over 2. Okay, you are actually doing the exactly same thing if you try to divide into 2. So yeah, you have theta is actually the angle here, right? So like what I say, if you actually divide the area here into 2 right angle triangle, then you will get the angle here as theta over 2. So that's why you have this is your O and you want to find your opposite. So that's why we are using sine. Okay, then after that, when you try to move around, then this is the exactly the same thing that you will get. Okay, so if you want to find out the area for this part, then you will be using your area for your sector to actually minus the triangle here, which we will talk about how to find the area of triangle. Okay, but if let's say yeah, I mean it's okay, you just remember that, then you know that AB is actually referred to your radius, then you will be using r square lah. Okay, so I do not want you to actually memorize, but try to understand everything that you have. Okay, so now we'll be looking at the solution for triangle. So for the first one, we are talking about the right angle triangle, so which this is the part where you should be very familiar with already. Okay, so two things that we always use. So if let's say this is your O, this is your A, sorry, yeah, I'm just going to put this is the theta lah. Okay, so opposite, so the hypotenuse is the longest side, so it's the side that opposite of your 90 degree. So the side between the angle that you have and the 90 degree is called as A. So after that, you left with one more, which will be the one that opposite of your angle, then it's called as opposite. Okay, so you will be using your SOHCAHTOA here, so which means sine theta will equals to O over H. So cos will be equals to A over H, then tangent will be equal to O over A. Okay, and don't forget under right angle triangle, you also have Pythagoras theorem. So we are just going to write 1, which means if you do O squared plus A squared, it will be always equal to H squared. Okay, Pythagoras theorem. Okay, so the next one that we are going to look at is sine rule. So yeah, I'm sorry that I can't draw a triangle that is like different side, so you just assume that it's actually different side. So if let's say I have A, B, C, so the one that opposite of the side will be the capital letter, which is the angle. Okay, so sine rule tells us that if A over sine A, then it will be also equal to B over sine B and also C over sine C. Okay, so you can see you do not need to use the whole formula. Normally you just take the first half or the second half, or like you take out the middle one. So what is important that you understand, sine rule applies in a triangle where you have like a pair of angle and the length. So which means if let's say you have A and A, then after that you have B and you want to find out what is your small b, then you will be using sine rule. Okay, so normally in two scenarios that we will try to use this, which is the first one is you have two angle at one side. Okay, then after that for the second part is you have two sides and also one non-included angle. not included, which means like it's not the angle that between the two sides that you are having. Okay, so for example, in this case, if let's say I have C and A, which means I'll need to have A or C, then only I can find the other angle, right? Yeah, so that's the idea. Okay, so yeah, so just remember sine rule works in a way that it must be in a pair for the pair that you have, and also the one that you want to find. So if let's say you want to find the side A, which means you also need to have the angle of A. So if let's say you want to find the angle of B, which means you also need to have the length of B. Okay, so that's the idea. Then after that, the second one is you have your cosine rule. Okay, so for cosine rule, then I mean this one is easier in a way that it's either you have two scenario. So for the first one is the formula is a square. Sorry, let me try to scroll it a bit. Okay, so the first one is a square plus b square. Sorry, a square equal to b square plus c square minus 2bc sine cos a. Okay, so this is the formula that you want to find a side if let's say you have two sides and one included angle. Okay, so your BC is your two side, then after that the included angle will be the A that you substitute here, then you want to find the other side. Then you have the second one which is very helpful if let's say you have three side. Okay, so for the first one, it is in a way that you have this one, and also this one. Okay, then you want to find here. Then after that, for the second one is you rearrange the whole thing. Okay, which after rearrange, you can imagine if let's say I try to move negative 2bc cos A to the front, and I move A square to the other side, then which I will have 2bc cos A equals to b squared plus c squared minus a squared, right? Then after that, I divide the whole thing by 2bc, which I will be able to get cos A will be equal to b squared plus c squared minus a squared divided by 2bc. Okay, so this is very helpful for you to get your angle if let's say you have three sides. Okay, but you must just make sure that the side, the angle that you want to find, all right, the angle that you want to find, the one that you substitute as A must be the one that is corresponding to your A. So which means if let's say now you have, let's say 1, 2, 3. Okay, so if this is the angle that you want to find, right, which means that your BC will be these two sides, and the A should be the one that is opposite of your of the angle that you want to find. So it's the same thing as your previous equation. So the A must be the one that's like corresponding, okay, or the one that opposite to each other. Then the last one, we talk about the area of triangle. Okay, so for area of triangle, whenever that you want to find area of triangle, right, you must need two sides and one included angle. So if you do not have enough information, that you might need to use sine rule or cosine rule to actually help you to get the information that you need. Okay, so the idea is that if let's say you have AB, which means you also need to have here. Okay, so the area for triangle will be equal to 1 over 2 times AB sine C. Okay, so two sides and one included angle for you to get the area for your triangle. Okay, so for this four solution, right? So you see in your circular measure that when we talk about arc length or area of sector or even the chord, right? All the data that we are using is in the form of radian. So that's why if to make the situation like much more easier for you, right? Whenever that you try to use this formula involving sine cos tangent, your angle actually can be in radian as well. It's just that you must make sure that your calculator, the mode, must be changed in radian, then only you can use. Alright, So which means that if let's say I want to do right angle triangle, so which means I have OH and I want to find my theta, right? So it's unnecessary for you to actually find out your theta in degree, then after that you try to change it in radian. So you just change your mode in your calculator into radian, then after you shift sign, you will be able to straight away get your theta in radian form already. So that's why when you try to solve all the questions that involving circular measure, it will be very helpful for you to just solve everything in radian. Then, I mean, of course, when you try to use your calculator to straight away get your answer, it will be definitely much more accurate than the one that you find it in degree, then after that you convert again. Okay, so the original one which you straight away get it from your calculator in radian, then that one will be much more accurate. Okay, so this is the part for circular measure, and I think it's very helpful for you to actually go through the past year paper, because I mean, in terms of like the content itself, it looks like very easy, but actually in the questions itself, right, sometimes it's very difficult for you to see like where's the part that you can start or you can solve. So I think some of the questions are actually quite tricky as well. So it's good that you can expose yourself to like different questions, then you will be able to understand the idea and try to apply what you have in all I mean in all the way that you have learned in this chapter. Okay. Alright, so that's it for topic 4. Thank you.